Hello everyone. My name is Preet Devgare. I am from Amravati, Maharashtra, and the topic we are going to discuss today is renin-angiotensin-aldosterone system. Renin-angiotensin-aldosterone system. Okay, shortly known as RAAS pathway. Before understanding this pathway, we have to look at what is GFR, that is glomerular filtration rate. Now, whenever the word rate comes, it means something per unit time. So we will try to understand what is GFR first, and then we will move to RAAS. Okay. So, considering your cardiac output, which is near about 5 liter, which we have already learned from circulation chapter. So if you see cardiac output, it is nothing but stroke volume into heartbeat per minute. Okay, your stroke volume is 70 ml blood and heartbeat is 72 beats per minute. Now multiplying this, we will get cardiac output, that is near about 5 liter, right? It means the heart pumps 5 liter of blood per minute. Out of which, how much amount of blood comes in kidney? That is your renal blood flow. The amount of blood flowing inside the kidney is your renal blood flow, and out of this 5 liter, near about 20 to 25% of blood flows in both the kidneys, not in single kidney, both the kidneys, which is 1000 to 1200 ml. So this becomes your renal blood flow. Okay, now if this much amount of blood is coming inside the kidney, how much filtrate is formed? Okay, so out of this 1000 to 1200 ml blood, 125 ml of filtrate is formed per minute. Where is the filtrate formed? So suppose this is your Bowman's capsule. The blood is coming from afferent and exiting from efferent. So I am saying 125 ml of filtrate is formed. So filtrate is actually formed here. Okay. We call it ultrafiltration. So considering the location of the filtrate form, ideally 125 ml of filtrate must be formed. But what if the GFR lowers down and it reduces to 100 ml or sometimes 90 ml? That becomes your abnormal GFR. Now this is normal GFR, glomerular filtration rate. Let's write it. Glomerular filtration rate. What if it goes down and from 125 it goes to 90 ml only? Then it's not a normal condition, it's an abnormal situation. We have to handle it. So if it goes down, this system gets activated. Okay, so first step is in your blood. Angiotensinogen is released by liver. See which organs are taking participation here. First participation is by liver and it contributes angiotensin from its side. It releases angiotensinogen in the blood. Second, when angiotensinogen flows in the blood, it will come in contact with renin. It will come in contact with renin, which is actually secreted by kidney. So it is the second organ. It is released by kidney. In kidney, where it is released from? So there is DCT, there is afferent, and then there is efferent. So if I am drawing the Bowman's capsule like this, and if I am drawing your glomerulus like this, so I will give it red color. Okay, and here is your DCT. This is your DCT. So the cells from DCT and afferent, when comes close to each other, they form something called juxtaglomerulus apparatus. So this is the region. This particular region is juxtaglomerular apparatus, in which there are some cells called macula densa. Macula densa, to be specific, will release renin. We can say that juxtaglomerulus apparatus is releasing renin, but if you want to be specific, macula densa is releasing renin. So from your kidney, renin is coming. Now when renin comes, angiotensinogen converts into angiotensin 1, and when angiotensin 1 comes in contact with angiotensin converting enzyme, now pay attention to this, angiotensin converting enzyme, short form is ACE. When it comes in contact with, when the angiotensin 1 comes in contact with angiotensin converting enzyme, it converts into angiotensin 2. Now the question is, where is this coming from? So it is coming from the third organ which is involved, and that is lungs. It is released by lungs. So now angiotensin is finally formed. This is the main hormone that we have to talk about. See, we will follow it by the definition renin. Okay, now angiotensin is also formed. Fine. Next we have to go to aldosterone. We will see how aldosterone is formed, but before that, the main function of angiotensin is vasoconstriction. So I will write down some functions. First is vasoconstriction. Which vessel gets constricted? Efferent. Okay. So vasoconstriction of efferent. When efferent get constricted, this is the efferent, its diameter will reduce, and it will automatically create some pressure here in this area. So your glomerular hydrostatic pressure, this is glomerulus, pressure is getting created by hydro, means water. Okay. Now is it water exactly? It is plasma of blood, that's why hydrostatic. So your GHP increases, and we can say if efferent is constricted, the pressure will actually apply on the filtration membrane, and that's why your filtration rate increases. So first function it does is vasoconstriction of efferent arteriole. Second is it releases ADH, and we know ADH is for water absorption. Third function is it acts on adrenal cortex. This is your adrenal gland, this is adrenal cortex, and the cortex releases aldosterone. Again, aldosterone reabsorbs water and salt. Okay. Now we are talking about aldosterone finally. First we talked about renin, then we talked about angiotensin, now we are talking about aldosterone. Now what aldosterone does? It reabsorbs H2O plus salt. Now suppose water is getting reabsorbed in circulatory system, then blood volume will increase because water is entering inside the blood. Blood volume increases, that's why blood pressure also increases. If blood pressure increases, the pressure of the blood coming from afferent arteriole will eventually increase, and when pressurized blood enters in the afferent arteriole, it will also put some pressure on the filtration membrane, and now more filtrate will be formed because there is pressure in the blood. Okay, so when more filtrate is formed, we can say that your value of lesser GFR can be taken back to normal GFR because now there is more filtrate formed per minute. So from abnormal condition we can achieve our normal condition again with the help of renin, angiotensin, aldosterone system. Okay, I hope you get it. Must have understood it. Thank you.